Hey everyone, in this video we're going to talk about using a problem-solving model for a one-step subtraction problem. So the first thing I need to do when I'm using my problem-solving model is I need to set it up with our first steps, which is looking at the problem and thinking about what do I know, what do I need to know, and is there a hidden question. So first and foremost, the problem is a factory produced 832 toys in a day. If 289 toys were sold, how many toys are left? So the very first thing I need to do is I need to make my know section. Okay? And so in this, what do I know? Well, one thing I do know is that a factory produced 832 toys. So that meant they had 832 toys. So I'm going to put that in my know. They had 832 toys. And then I'm going to keep reading. And I see 289 toys were sold. Ooh, that's an important detail. 289 toys were sold. And so I need to make a note that means I no longer have them. All right, now I keep reading. Oop, and I'm to my need to know. I'm to my question. And my question is, how many toys are left? So in my need to know section, I'm going to go ahead and write that in. How many toys are left? All right, now I would start thinking about my hidden question section. So a hidden question is seen in multi-step problems. And it's called a hidden question because it means it's talking about something that needs to be solved before you can get to your final question. However, we may note that this is a one-step problem. We already know it is a one-step problem. So if one-step problem, I already have my information and I just need to do something with that information. I need to see what I need to do. Do I need to add, subtract, divide, multiply in order to get my final answer? There is no hidden question. So what I can do is put an X in that to make note that there was no hidden question. Now we move on to our next part, which is where we make a plan and we solve. So when I say make a plan, that can include things like a strip diagram, an equation, a number line, but what you'll see most common is us using a strip diagram or an equation. And so again, when you go to make a strip diagram or an equation, you do the same thing we did filling out our know and our need to know. You read through the problem and figure out what information do you already have and what information do you need to find. So if I'm doing that, I see that the first thing I had was 832 toys. So I'm going to draw a box for that 832. Okay, so that represents my 832 toys. Okay, so then I have to keep on reading. It says if 289 toys were sold. Well, I have to think about what does that mean if it was sold? Well, if it was sold, it means I no longer have it. It means it was taken out of that 832 toys. So in my strip diagram right here, I would not put it right there beside it because that would mean I'm adding that 289 toys to my 832 toys. But I didn't add any toys. Those 289 toys came from my 832 toys. So if I took it from that, that means I would be placing it right down underneath it. Because I would need to subtract them to find what is in this space right here. And so now we have to think, what's in that space right there? Well, if I answered what 832 minus that 289 was, it would tell me how many toys are left. And I'm going to put T right here for toys left. All right, if I set this up as an equation, it would look like my starting number, which was 832. And then we sold 289, which means we no longer have them. So we took those away, which would be our subtraction. And once I do 832 minus 289, I will be left with T, which represents how many toys are left. All right, so I figured out what I know and what I needed to know. I made a plan. Now we get to solve. All right, so in my solving, that's all you do is you solve. So I'm going to choose to do my solving using my place value strategy. So that's when I do 832 minus 289. All right, and then I expand them out. So that becomes 800 plus 30 plus 2. And then this becomes 200 plus 80 plus 9. And I have to remember my big action. I already have it right here, but I am subtracting. I'm not adding them together. I am subtracting. All right, so I always start on that right side. Okay, I start over in my ones place on this. So I see that I need to do 2 minus 9. Well, thinking about that, I can't do 2 minus 9. You can't do 2 minus 9 without getting a negative number. So I'm going to have to regroup, which means I go over here to my tens space, and I would be taking one of those tens. So it's like I was taking a rod. So my 30 will become 20. And over here, I'm going to add that 10, which makes my new number 12. And now I know I can do 12 minus 9. 12 minus 9 is 3. All right, now I move over to my tens place. Now my new my new top number is no longer 30, but it's now 20. My top number is now 20, not 30. So I'm doing 20 minus 80. Well, I can't do that either. So I have to go back and regroup again. However, this time I'm taking from my 100 space and bringing it to my 10 space. So I would be taking 100 from this, which would leave me with 700. And I'm going to come over here and I'm going to add it to my tens place, which would leave me with 120. All right. Well, 120 minus 80 would be 40. All right. And now I'm in my 100 space and I can see 700 minus 200. Well, I know I can do that. And I know that's going to leave me with 500. And 500 plus 40 plus 3 is 543. Right? And then this very last section down here is your justify section. So this is when you are double checking your work using a different addition subtraction strategy. It's thinking about how all of our numbers connect. You could do an estimate solution, so round your numbers to get an estimate or about how much you should have gotten. So what I'm going to do is I'm going to think about the connections that our numbers have, because we solved it and we saw that 832 minus 289 equals 543. Well, if this was true, then that would also mean 832 minus 543 would equal 289. I could also do it a different way and bring in addition, because as we saw up here in this section, this part, my 289, and this part, my T, which we now know was 543, if those were combined together, it should equal this 832. So what I can do is I can take that 289 and I can add T, which we figured out was 543. And if it's correct, it should equal 832. So let's check it. So 289 plus 543. Gonna stretch it out again. 200 plus 80 plus 9, and 500 plus 40 plus 3. So I have to think, what is 9 plus 3? All right, well, 9 plus 3 is 12. However, I can't necessarily put 2 digits in this spot, but I know if I have 12, that means I have 1 rod or 1 10 and 2 units or 2 ones. So I can leave my 2 here, and I'm going to take those 10 units that make 1 rod or make 1 10 and go put it over here. What that would look like in this section right there would be 9 plus 3 is 12. So I put my 2 and my 1 would go there. So now I'm doing, what is 10 plus 80? Well, 10 plus 80 is 90. And then I have to add my 40, and that would equal 130. Well, I know in my 10 space, I can't put just 130. So what I need to do is I would leave my 10s, which was 30, and I would push that 100 over here. What it would look back at that standard form right over here again, what that would look like is we know 1 plus 8 is 9, plus 4, which would be 13, but I can't put 2 digits in that one spot. So I need to place my 3 and move my 1 over to that hundreds place, because technically that didn't represent a 13. It represented 13 rods or 13 tens. So those 3 tens could stay, but that group of 10 tens, which would be 100, was moved over to my 100 spot. So now I'm checking, what is 100 plus 200? Well, that's 300. And what is 300 plus 500? Well, I know that that would be 800. All right, so now what I need to do is I need to think about combining these parts to make it the complete number. So 800 plus 30 plus 2 is 832, and I can look over here. 1 plus 2 is 3, plus 5 would be 8, which is what answer we were looking for. Alrighty, guys, great job.